Hello everyone, my name is Naren and in this session let's talk about system design for Twitter. And I'm not going to talk a lot about what technology specifically Twitter uses, but instead I'm going to talk about the core concepts like how to generate user timeline, how to generate home timeline, how to calculate the trending hash for different locations in the whole world, and also the data flow through the system. What are the different features we need to support in this system design? First one is users should be able to tweet to the followers as fast as possible. Sometimes a particular user will be having about millions of followers to it. So he should be able to send this tweet to all of their followers in about few seconds. So the second feature is timeline. Basically everything you see in the Twitter is called as timeline, right? So there are different types of timelines. First is home timeline. Home timeline means basically the tweets from all the people or the pages which you are following. Whenever you open the Twitter, by default you land at the home timeline. The next is user timeline. This is specific to your timeline, that is all the tweets you made, all the retweets you made. Whenever you open your profile, you will see all the tweets you made, right? That is called as user timeline, and you should be able to see that. And also the search timeline, in which you're gonna search some keyword in the Twitter, and then you should be able to see all the tweets which are related to that particular keyword. And the next feature is trends. You should be also seeing all the trending hashtags or the topics to see what's going on in your location or in around the world. Before architecting any system, you need to understand the characteristics of that particular application. For example, Twitter has about 300 million plus users as of today. That means that we might be expecting a lot of reads and write. Twitter gets about 600 tweets per second writes. That means that there are people who are tweeting 600 tweets per second. And also Twitter gets about 600,000 tweets of read queries from the users. That means that if you see the ratio of write versus read, it is almost like 1:1000. For every one tweet generated, there are about 1000 people on an average looking out or reading that particular tweet, which gives us that the Twitter is read heavy. That means that we should have a system which is very good at reading all the tweets, and also it should also support about 600,000 tweets per second or query per second from this particular system. And also if we also see that Twitter is not like a banking application where you need to have data consistency. It's okay to have these tweets eventually consistent. Say for example, if I tweet, it's okay if my followers see this particular tweet 1 or 2 second delayed. It's not a big deal. So it's okay to have eventual consistency. And also, if we talk about storage, Twitter as of today has a limit of about 140 characters per tweet. That is a lot less in these days, right? Because the data storage cost is a lot less these days. So we don't need to worry a lot about storage cost, but we just need to worry about how we scale the storage and how we cope with this much of reads from the users. And I know you guys are curious to see how the system design diagram looks like, and here is a sneak peek. As we already learned that Twitter is read heavy, that means that we need a system which allows us to read the tweets or any data faster without loading the system heavily, and also it should scale horizontally. What is that system? So we can think of using Redis, because Redis is much faster as all the data will be stored in memory, and also which can scale horizontally, or we can build clusters out of it. And also we can't just solely depend on Redis because it is also persistent, but we can't just depend completely on the Redis. We have to have a copy of all the data in the DB. That means that the important database tables which we needed are user table, tweet table, and followers table. Whenever user profile is created, we have an entry here, and whenever he follows pages or person, we have to have a one-to-many relation between user and the follower, and that is shown here, users and the followers. And also as the user makes tweet, all the tweets are also saved in the tweet table, and that also has one-to-many relationship with the tweets. And all the retweets are also considered as the tweet for this particular user. So all the retweets, also a copy of retweets, either you can make a one-to-many relationship with the tweets itself, or you can save a copy of tweet in the user to tweet relationship. So that way, if the source tweet is deleted, we have a copy of tweet mapped to the user and Twitter tweets. So also we need to understand how we are going to save the data in Redis. In Redis, we need to design the key, how we can save the data. So obviously we need to have a user ID in the key and also some kind of unique identification. So user ID hyphen tweet string, which gives out all the tweets with which user has made so far. We can use the Redis own list data structure to save all the tweets. So with that, we can get all the different kind of operations which we can do on top of this list data structure. And also to have a mapping of user, user followers in the cache, we can have key which contains user ID and also hyphen followers, which gives you the list of all the followers which a user is making, and these IDs are the IDs in the table. Similarly, in the tweets, all these IDs are the IDs in the tweets table. So how do we get all the data to generate the user timeline? Say, for example, when someone visits a user's timeline, how do we get the data? To get the data, what we need to do is go to the user table, buy the user ID, get all the tweets, retweets, and the original reference tweet, and sort by the date and time, and then give back the data. This won't scale, or this won't work always, because we know that Twitter is read heavy. There are about 600,000 reads coming in, so we can't always just load the DB with all these queries. So what we need to do is we need to have one more layer called caching layer, and we save the data for this user timeline query in the Redis. Before that, what we need to do is when a user tweets, we also need to keep saving the tweet into the Redis. That way, when someone visits a user's timeline, what we need to do is by user ID, we can just get all the tweets which we have made so far. And this data is present in the Redis, so the read is much faster because all this data is in memory. Once we get all the tweets which a user is made by user ID and this key, we get all the IDs of the tweets which that user has made. Then what we need to do is by the tweet ID over here, you can get the exact tweet from the Redis itself. So 1_tweet, 2_tweet, like that. We can get all the tweet information which is saved in the Redis, which can also have other metadata. And all of the data we can just build the user timeline. Now let's see how to get the data which is needed to show in home timeline. It looks something like this, which contains all the latest tweet of the person you are following or the page you are following. And how to get this data? It is very simple, right? What you need to do is first get all the followers you are following. And then what you need to do for each follower, get all the latest tweets. And then you need to merge all these tweets and sort by date and time, and then display on the home page that shows all the latest tweets made by all the followers whom that particular user is following. Does this work? If you see, we have to get the followers. Hypothetically, every user will follow about 100, 150 pages, right? That means that we have to go to 150 pages or user table and then get their latest tweets. These queries are heavier on database. You can argue that I will shard or I will use NoSQL, I'll have multiple nodes, and all these nodes will take care of those many queries. But trust me, making 150 queries or even if it is 10 queries, it is not good. You can't return these response or the data which is needed to show home timeline much faster. If you would have seen that when you load Twitter homepage, it loads much faster. The APIs which serves the data for home timeline gives a response within like 200 milliseconds or even much lesser. How does they do it? For that, we need to do some different strategy. Let's discuss that. Let's see how do we get the data required to compute home timeline efficiently. The approach is called as fan-out approach. Fan-out means moving to different direction from a single point. That's the definition. Okay, let's see how do we use it. That means that whenever we get a tweet, do a lot of pre-processing and then distribute the data into different users' home timeline. That way we can reduce the queries we have to make when there is a request to compute the home timeline for that particular user. Say, for example, a user has been followed by 3 different people, and this guy, okay, has a cache timeline entry that is called as user timeline, and all the followers will also have user timeline and also home timeline, okay, and we also have DB. Now consider this guy made a tweet, and this is a tweet. Now what do we need to do is first add an entry into the DB. That means that we have saved the tweet in the DB. Now it is persistent. Now what we need to do is add the same tweet into his user timeline that already we discussed. So the tweet is added into user timeline. If you make a query to get the user timeline, this tweet is already there, and all the other historical tweets also there in here. Now what we need to do is send this data or fan out this particular tweet data to all the followers. What that means is send this tweet to all different followers whom following this particular person. When we send this tweet, it will get updated to this person's home timeline in the cache. So send this tweet into the home timeline. Entry has been added here, and this tweet added to this guy also, and this guy's. So this is all Redis entry, or considered as Redis array, Redis list as such. And this tweet has been added here. Okay. Now, whenever this guy visits his home page or home timeline, he just need to get the data from this cache. This cache or this array which is in the Redis doesn't just contain this guy's tweet. If there is one more person, if this guy is also following this guy, whenever this guy tweets, this entry will also come and sit here. Similarly, if this guy is also following this guy, when this tweet saves here, afterwards the same tweet will also be updated here. Now, there are 2 tweets in this home timeline of this particular user, and here also there are 2 tweets in this. If this guy is following some other page, whenever they tweet, that entry will also be updated here. So whenever this guy visits his home timeline, we just need to get this cache entry, which has all the tweets which are recently made by all these follower pages. That way you don't need to make any database query. All we need to do is just go to this cache by user ID, access the home timeline data in the Redis. As you know, Redis is much faster because it is in memory. We get this list. You just need to show those tweets in some ascending order by date and time on your home timeline. That's it. Somehow we reduced the DB queries completely. We are using Redis to get the home timeline data. But does this model works always? It doesn't. Sometimes. When it is? When consider this guy is a celebrity, some kind of like Taylor Swift or someone. He has like about 30 million users in Twitter. So that means that we have around 30 million followers to this celebrity. Okay, these many followers all following to this particular celebrity. When this celebrity tweets, is it an easy task to update this particular tweet into all 30 million persons' home timeline? It easily takes about minutes, even on Redis. So we need to follow different approach for dispensing the tweets made by the celebrities. Let's see how to do that. So let's see how do we handle tweets made by celebrities. Consider this guy is a celebrity. We'll name him as C. When this guy tweets, what do we need to do? Obviously, save this tweet into tweets table in the DB. Then add the tweet into user timeline cache. And then what we need to do is, if he was not a celebrity, then we would have fan out this particular tweet, updating all the followers' home timeline, right? But since this guy has about millions of followers over here, I can't update each and every one. It's too much. So that's it. You just need to do nothing. Just do this process and stay quiet. When the follower tried to load his home timeline, as we already saw in his cache, in home timeline cache, we have the tweets already updated by fan out of other people who are not celebrity. Now all we need to do is just return this data back to the front end or the application. But before doing that, let's check if he has any celebrity tweets. How do we do that? Let's also maintain in this user's cache, let's also maintain the list of celebrities whom he is following. Okay? And since it is in cache, this operation will be much faster. Consider he has about 5 different celebrities he is following. All we need to do is go to first celebrity in the cache itself, go to the user timeline of the celebrity, okay, that is first celebrity, and see if there is a tweet recently made. If so, get the tweet and then add it to the response. In the response, we have already added these 3 tweets, 1, 2, 3 tweets. We got 1 celebrity tweet, add it, that is 4th tweet, and next go to the next celebrity and keep checking that. Since all these operations are in-memory operations or Redis operation, this shouldn't take much time and it is much efficient. That way, we have included all the home timeline tweets and we have added all the celebrity tweets into the final tweets list for the home timeline in real time. That way, we got all the tweets which we were supposed to show in the home timeline of this particular person. Now that we optimize how to access user timeline and home timeline efficiently using Redis cache, now also optimize a little bit. Do we really need to calculate or pre-compute all these home timeline and user timeline for the users which are not even logging into Twitter recently? It's unnecessary, right? Because we simply calculating this home timeline and also user timeline for the people who doesn't even log into Twitter for about more than 15 days. That means that we don't need to compute home timeline for that guy. We save a lot of memory in Redis and a lot of computations also. So let's learn how Twitter trends are calculated. Twitter considers volume of the tweets and also the time taken to generate that particular volume of tweets. Based on this data, they determine whether this particular hashtag is trending or not. Say for example, 1,000 tweets in 5 minutes is much interesting than 10,000 tweets generated in 1 month. That means that in little time or short period of time, people are talking a lot about something, so they generated about 1,000 tweets. But 10,000 tweets in 1 month could be something which is pretty normal because the time duration is bigger. And the events are like, say for example, if there is an election results happened, so people must be talking about different parties or something else. Or there could be a cricket match going on, or there could be something like there is a movie release happened just now and people are talking about its reviews or something like that. And these are the hashtags which trends. How does Twitter process that kind of data? Obviously, it needs to go through each and every tweets which has been tweeted in the platform and then compute what hashtag is trending. What framework Twitter uses? Twitter uses stream processing framework like Apache Storm or Heron. Here is the system designed for stream processing of the tweets to figure out what is the trending hash tag or keyword. Okay. Now you can build this system using 2 or more different kind of frameworks. Like you can use either Apache Storm to build the whole thing, or you can use Kafka Streams also to build this kind of system. There are many other stream processing framework which you can try once. Okay. Now Before explaining, remember all these things happens in real time. That means that if a person tweets on Twitter, the tweet actually goes through this kind of pipeline also in real time. So these boxes are, you can think it as like operators. Each has its own functionality or function. Say for example, this is a filter function or filter operator, and this operator's work is just does to filtering of tweets based on certain criteria, and I'm going to explain that later. And this guy's work is passing. So just that, every operator here has its own designated functions, and they do that only. And how do we scale this kind of system? So we have tightly coupled these operators or operations. How do we scale it? Say for example, this is fast, but geolocation tagging is a little slower. How do we scale? In that case, only we need to do is just scale this operator. Add more operators which does this operation. Rest all you can keep like one operator. It's not ideal situation, but just for the comparison purpose, when all these runs on one operator, maybe this guy or this particular operation takes some time to geotag or something. That is the reason we'll need to scale only this thing. All this data flows through some kind of buffer or kind of queue. And it depends on what technology or what kind of framework you are using. If you are, say for example, if you are using Kafka Streams, all these different operators are connected by a queue, a topic of Kafka or something like that. So what happens now is when a person tweets, the message enters into this filter through a queue. That could be Kafka queue or any other queue. This tweet is pushed to Kafka queue, and then from the Kafka queue, this filter has picked up that message. Okay. Now what this filter operator does is, it obviously knows the Twitter guys have updated some of the filters. That's kind of manual job. That most common frequent hashtags, which doesn't qualify as a trending hashtag, like say fun, travel, food, quotes, all these kind of lame hashtags, right? We don't even consider them as a hashtag which can go as a part of trending hashtag, right? So we have to filter all these hashtags from the tweets if there are any. So this filter operator does that, and also it checks for any violation check if a particular tweet has crossed the violation or not. Like violations like, does it have any adult content, or does it have violated any copyrights, something like that. If it violates, then that tweet is dropped and not processed further. Then once this processing happens, this message, whatever we have that with all the metadata, will be put into the queue, and then this guy picks up. The advantage of having queue in between these operators is, say when we scale this operator to even many more operators, then these guys, based on which operator is free, they can pick the messages easily. Like all this works asynchronously. So what this parse operator does is, it parses the tweet. Not always every user mentions the hashtag of a particular tweet. In that case, somehow Twitter needs to figure out an appropriate hashtag by doing some kind of natural language processing or some kind of that kind of process. And then we need to assign a hashtag to it. It makes sure that at least one hashtag is associated with any given tweet. And also while parsing, we have to remove all the stop words. Stop words are like the normal, any words which doesn't have meaning, like to, the, as, of, now, etc. Those things. Remove all of that. Pick all the important words in the tweet, and then based on that, figure out an appropriate hashtag. And now from here onwards, the data, the tweet will get distributed into two different pipelines. One for the geo processing and another for the trending processing. In here, the tweet, a copy of the tweet is also passed to this pipeline and to this pipeline also. Now, I'll explain one pipeline and then we'll consider another thing. Now the tweet is here. Now, as I already mentioned, before computing the trending hashtag, we need to consider two things. The time taken to tweet those many tweets, and also the number of tweets which have made so far. That means that we need to do kind of window operation on all the tweets which we have received so far. So we kind of do a window operation here on all the tweets received so far, like say 1 minute window, 10-minute window, or 1 hour window. Based on that, we will get the count of any given hashtag, like kind of rate at which these hashtags are produced in the Twitter platform. Now, once we have the rate, now that particular data is forwarded to the rank operator. In here, what happens is the rank operator figures out or gives a rank to each and every hashtag which this particular operator sees so far. Based on that, we know what hashtag is trending. But Twitter is present everywhere. That is, most of the countries in the world, right? Except a few countries like China. So just figuring out the hashtag doesn't make sense, because say an election is happening only in United States, that means that hashtag election might not be a lot suitable for a different country like Australia. Maybe that's a bad example because the whole world watches US elections. Say, for example, a rugby match is happening in US. In that case, that hashtag rugby is not appropriate in a country like Pakistan, right? So we have to also consider the fact that we also need to map these hashtags with geolocation or location. So the same tweet is passed to geolocation operator. Here, this particular operator is responsible to figure out an appropriate location or country for any given tweet. It figures out that, and the same thing happens, like some window operation, do a mapping of location to the hashtag on a window operation, and then figures out what particular hashtag belongs to which particular location. Then all this data is fed into the Redis. From the Redis, any API can read that data and will be consumed by the Twitter front end or application. So that's how it works. I'm not going to explain in depth. To understand more on how this streaming framework works, please go and read a little bit about Kafka Streams and Apache Storm. Then this will make a lot sense to you guys. And now let's learn a little bit about how Twitter search timeline works. Let's see how Twitter handles searching of its tweets and hashtags. Twitter uses something called as Earlybird. Internally, Earlybird what it does is inverted full text indexing operation. In simple word, how inverted full text indexing works is, say for example, every time when a tweet is inserted into the Twitter or updated in the Twitter, that tweet will be broken into different tag words and also into hashtags. And then all these words are then remapped or indexed to all the different tweets. Say for example, when the tweet is broken into 4 different words, hi, thank, super, and movie, and also other hashtags. And now these words are indexed. And how does that happen is, say it has a big table or distributed table in which each word has a reference to all the tweets which contain that particular word. Say when I search for the word hashtag tank, what happens is all we need to do is look up through the table and then find a word or hashtag called tank, and then figure out all the references to all the tweets in the system, and then just give out that result. Say for example this complete result. Now that I also said it is distributed, because you can't have just one system, one big table to handle all of this data, and that is a single point of failure. So obviously we need to go for distributed computation. So Twitter does that too. That is something called, the strategy is called as scatter and gather. You have different nodes which is scattered across different data centers. When you get a query, you send that query to all the different nodes or data centers, and then each data center looks for all the tweets which it knows for that particular hashtag or for any given keyword. And then all these nodes or data centers gives back all the result, and then the search system collates all the results which it gets so far and then returns back that particular output. That's the list of all the tweets based on the popularity. So far we learned how search works, how timelines are computed or how timelines are calculated, and also how trending hashtag is also calculated using stream processing. Now it's time to learn how data flows through the system or system design for Twitter. And here is the system design, and I have already explained most of the important components in this system design. Now I'm going to explain a little bit about how the data flows through the system. Say for example, if a person tweets, that message or the API call hits the load balancer, and then that call hits the Twitter writer. And these are the API which is responsible to handle the tweet or incoming tweet. What it does is, as I have already explained, the tweets are updated in two different components. First, a copy of tweet is saved into database, and then a same copy of tweet is also sent to Apache Storm for hashtag trending hashtag computations, or to figure out the trending hashtag. And also a copy of tweet is sent out to Fanout service. As I have already explained, Fanout is the service which is responsible to update the tweet into all the followers' timelines, like home timeline and also user timeline. Once it gets the tweet, it updates in all the timelines, all the home timelines of the followers of a given person. And also a copy of tweet is also sent to the search service, as we need to index or break down the tweets into different words, and then these words are indexed to make it better searchable, and that is handled by search service, and it's also called as early bird in Twitter. When user searches for some hashtag or some word or some keyword from the application, now what happens is the search request or the search API call lands load balancer, and then the request is forwarded to timeline service, and in turn timeline service transfers the call to search service. In here what happens is search service scatters the request. That means that it calls all the different nodes or data centers, or it sends the same query to all the different data centers, and then it collects all the results from those data centers and then send back to the application. And also few more other scenarios are when the user requests for home timeline or user timeline, those API calls also hit the load balancer, and then that request will be forwarded to timeline service. The timeline service directly talks to the Redis, and it figures out appropriate or the timelines for a user or home timeline in the Redis, and then it is much faster. It retrieves those timelines and then gives back to the application in the form of JSON. And here you can see that there is HTTP push or WebSocket component which is responsible to handle the real-time or persistent connection with the mobile applications. It could be Android or iOS. It handles the WebSocket connection, and this service should be able to handle millions of connections at any given point of the time. And here you can see Zookeeper. Zookeeper is a coordination service for distributed components. Say for example, we have a number of nodes. Actually, Twitter runs about thousands of nodes in any given cluster just for Redis, because most of the data is present in Redis, and also a copy of data is permanently present in the DB. So we need to have a big cluster of Redis, right? And when we have big cluster, we also need to coordinate between these nodes, and also we need to have a master who is responsible to coordinate with other nodes, right? All this work is done by Zookeeper. Basically, Zookeeper helps you to maintain the configuration for each and every node in the cluster, and also it maintains it helps you to elect a master in this Redis cluster, and also it can be used to name the servers automatically. And also the Zookeeper keeps tracks of what are the servers online at any given point of time, or what are the servers which is offline. Based on that, it coordinates with all the nodes in the cluster. I think I have explained all the components over here. Finally, DB. Twitter uses something called as Gizzard, which is built on top of MySQL and InnoDB, which is again distributed service. Since most number of calls are not going directly, or most number of queries are not going to database, we don't need to worry too much about DB. But still, at Twitter scale, we need to make sure that DB scales as there are more number of users signing up to the Twitter. And also, Twitter uses Cassandra DB for some of the other computations, like for some kind of analytics and other kind of services where we have a big data and we need to run some kind of analysis. I think that's about it. I think I have covered all the major components or the services which are needed to design the Twitter system. Yep. If you like this video, please subscribe to my channel and also tell your friends about the channel. And please leave me the suggestions on how I can improve these videos. And also, if you have any specific topic, please drop a comment in any of the videos. I'm going to reply to each and every comment. Thank you.